In this video, this is a continuation of our series on Mr. John Coburn's Precalculus. This is going to be a walkthrough of exercises 1.3. It's all about the graphs of sine and cosine functions. Originally, in the textbook, there are graphs of secant and cosecant functions, but this video will only cover sine and cosine. Yeah. Our teacher made discussions about functions of all the trigonometric stuff such as sine, cosine, tangent, cotangent, cosecant, and secant. But I couldn't make sure of the teaching materials of other functions that are not sine and cosine. So this is what I can salvage so far. Let's start. So based on my understanding on this part of the exercise, we started at number 9a. We use the characteristics of f of t is equal to sine t to match the given value of t to the correct value of sine t. So I hope you have your scientific calculators with you. We're going to make use of it right now. Always make sure to set your calculator in radians, since right now we are currently dealing with things that are in radians. Make sure that your calculator isn't set in degrees, therefore. Okay, so for letter A, just put in the calculator input pi over 6 plus 10 pi. What you eventually get is sine t is equal to 1/2. This is 1/2 in the calculator. So as you can see here in number 9, we have choices for each letter. So 9a, 9b, 9c, 9d, 9e. They all correspond to each value in the choices. So sine t is equal to 1/2. This is 2, and this is the final answer. Okay, so let's go for letter B, sine negative pi over 4. So negative pi over 4 is basically negative square root of 2 over 2. That's number 5. So for letter C, we input the values. We get sine t is equal to square root of 2 over 2. Basically the positive this time. For letter D, sine 13 pi is 0. So apparently it's number 1. For letter E, sine 21 pi over 2 is 1. And that's number 3. So that's it for the first part. Let's move on to number 10. So right now, apparently for letters A, B, C, D, and E, basically everything in number 10, there's no sine. But wait, yeah, there's no sine, but we'll just integrate sine as stated here, and yeah, just input the values here in the calculator. So sine, open parenthesis, pi over 4 minus 12 pi is equal to square root of 2 over 2. That is IV. For letter B, sine 11 pi over 6, we get negative 1/2. Negative 1/2 is I. For letter C, sine 23 pi over 2 is negative 1. So that's V. For letter D, sine negative 19 pi, we get 0. That is 3, or I. For letter E, negative 25 pi over 4, we get sine t is equal to negative square root of 2 over 2. Which is this one. Okay, let's move on to number 11. So use steps 1 through 4 given in this section to draw a sketch of each graph. So I think it's best to make generalized conclusions first before we even start all this. This is going to be a lot. Okay. So sine and cosine functions. For sine, based on a particular graph like this, if the sine is a positive function, it basically starts from here, like that. I'm sorry. If the sine function is negative, then the curve would start from below. So that's something basic that you have to remember. For cosine function, one observation pala for sine functions is that you start from the point of origin, or the 0, 0. If it's positive, from the point of origin, you ascend first. If the sine function is negative, you descend first. Now, for cosine functions, if it's positive, you start from the amplitude. By the way, the amplitude is the crest and trough of your graph. So that's basically the very top and the very bottom of your graph. So cosine function, if it's positive, we descend like that. And if the cosine function is negative, we ascend from the bottom. So what you can take note of as a distinction between sine and cosine functions is that for sine, the curve starts at the point of origin. For cosine, it starts at the amplitude, whether on top or below. Okay, so we can officially start. So in number 11, y is equal to sine t for t is an element of negative 3 pi over 2 and pi over 2. So basically what is stated here, those are going to be the values in the x-axis. So given a particular line like this, they are going to be the values here. The values on the y-axis would be the amplitude, usually only the two of them. But first, you have to know that you have to take note of this. The period is equivalent to 2 pi over b. Y is equal to cosine t. Y is equal to sine t. What's the blue annotation here is the amplitude, and the letter green annotation is to b, the denominator of period. Even though there's no specific terminology to represent b, it is instrumental in graphing your sine or cosine function. So for number 11, we start at negative 3 pi over 2, so that's at the other side, the left side of 0. This is pi over 2 right here, I suppose. By the way, I'm sorry about this, but there is one thing that you also might want to take note of. So in the usual y-axis, assuming that point of origin is here, the next value will, based on the unit circle, will be pi over 2. The next would be 3 pi over 2. I'm sorry. It's going to be pi, and then 3 pi over 2, and then 2 pi. Basically, if you convert them in degrees, pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, and 2 pi is 360. Proof? Try converting pi over 2 in degrees. So we just multiply the theta value in radians, from radians to degrees. So based on the calculator, this is 90. Now in number 11, pi over 2, that's the maximum in our element set. So let's focus on the other side. So here is negative pi over 2, negative pi, and then negative 3 pi over 2. I hope you're getting the pattern. If this is at the right side of the x-axis, what's on the left side? Let's extend this more. So the negative side, it's negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So they basically translate to negative 90 degrees, negative 180 degrees, negative 270, negative 360. But that's something that you don't have to take note of in all seriousness. You just have to be knowledgeable or be familiar about the sequencing. This is the usual sequencing in most graphs. But of course, each function is different in its own way. It's unique. And that's what makes it complicated. At least in my perspective. I hope you've taken note of it. If you haven't, you can get back to that part of this video, but yeah. Right now, let's make the table first. And before making the table though, you have to know the amplitude and the b value. So the amplitude is based on the function itself. Amplitude is here. So the invisible number will always be 1, so the amplitude is 1. And the b value is, so sine t. There's no coefficient or visible coefficient between t and sine, so obviously b is 1 also. Now let's make the table. So given t, the t values will be negative 3 pi over 2, negative pi over 2, 0, and pi over 2. Basically all the elements in this set. And we list here sine t and b times t. We write the graph this way. So all the values here will be derived from assuming that you put sine on each of these t values. So for instance, sine negative 3 pi over 2 is 1. So whatever is here in sine t, it's basically going to be the amplitude. So because your amplitude is 1, whether your sine function is positive or negative, the amplitude will always be 1 since it's an absolute value. And right now it's going to be in the graph it's going to be 1 here and negative 1 at the bottom. So let's see if that's true. Sine negative pi is 0. Sine negative pi over 2 is negative 1. Sine 0 is 0. Sine pi over 2 is positive 1. Now let's look for the b times t. By the way, if we're looking for the b times t, it's just the, how am I supposed to say this? Right now it's not too strict since because the b value is just 1, we just basically copy everything from t. They're just the same. And so right now we just tally the values that we have found. bt will be the x value, so, and sine t will be the y value, the amplitude. Alright, so now that we have these, we can point them out in the graph. So apparently we already have the illustration. You just have to plot the points. So for negative 3 pi 2 and plus 1, it's over here. Negative 3 pi 2 and plus 1. Negative pi and 0 is here. Negative pi over 2 and negative 1 is over here. 0, 0, point of origin, and pi over 2 and 1 over here. Now let's try to graph it. So the graph looks something like this. I apologize for the terrible drawing, but yeah, the graph should look something like that. The curves should be a lot more dramatic, but yeah, that's just a mere illustration of number 11. Let's go for number 12. In number 12, it's a little actually I've already given the a and b by the way, b times t equal to 1, you can just say bt is 1. But it doesn't mean that bt and b is equal to each other. It depends on the circumstances, but right now, because it's y is equal to sine t, there's no number or visible number in between sine and t, so bt is still 1, which is equal to b. And the amplitude is still 1 since there's no other number here except an invisible number that is 1. So the element set over here states that we range from negative pi. So negative pi, this is this is 180 degrees, and what comes next is 90 degrees, which is negative pi over 2, and then 0, then pi over 2, this time it's positive, and pi, positive 180. So right now, sine t, we just multiply the t values with sine. We get 0, negative 1, 0, positive 1, and 0. And for bt, we have, because b is still 1, we have negative pi over 2, 0, positive pi over 2, and positive pi. So let's tally the results. Negative pi and 0, negative pi over 2 and negative 1, 0, 0, pi over 2 and positive 1, pi and 0. Okay, let's make a graph of it. By estimation, let's put the point of origin somewhere here in the middle. Pi over 2 and pi. Here we have negative pi over 2 and negative pi. So negative pi corresponds to 0. Negative pi over 2 and negative 1 here. By the way, I forgot to insert the amplitude value. So here is positive 1, here is negative 1. The point of origin is 0, 0, pi over 2 plus 1, and pi 0. So we have something like this. As you can see, based on something that I mentioned earlier, because number 12 is a positive sine function, from the point of origin, it ascends. Also in number 11, because the sine function is positive, from the point of origin, the line ascends. That's one good observation that you might want to take note. Let's move to number 13. So y is equal to cos t. So this time it's a cosine function. And I forgot to erase the amplitude and the bt value. But right now, as you can see, between cosine and t, there's no number. So apparently, b is still equal to 1. It's equal to bt. But this won't be a necessary value. Just take note of a and b. A is the amplitude. Supposedly here, it's an invisible number. If there's no number, then it's obviously 1. So the set element, we have negative pi over 2, which is negative 90 degrees. What's next is 0. And we have positive pi over 2, which is 90 degrees. In other words, we have pi, which is 180 degrees. 3 pi over 2, which is 270 degrees. And 2 pi, which is 360. So, similar to what we did in numbers 11 and 12, we multiply the t value with cosine. With that, the results are 0, 1, 0, negative 1, 0, and positive 1. And because the b is still 1, we just copy the values from t. Nothing changes at all. So negative pi over 2 and 0, 0 and 1, pi over 2 and 0, pi and negative 1, 3 pi over 2 and 0, 2 pi and 1. Those are the points in our graph. Now let's make the graph. Okay, so our point of origin is here. Negative pi over 2 is here. Positive pi over 2 is here. Pi is here. 3 pi over 2 here. And 2 pi here. Now, let's list the amplitude. Positive 1 here. Negative 1 here. Negative pi over 2 and 0 is located here. 0, 1 here. Pi over 2 and 0 there. And the rest goes on. Now, let's start outlining. Make the curve. So yes, our graph would look something like this. Let's move to number 14. So, as you can see, the amplitude is still 1. The B is also still 1. The element set is from negative pi over 2. Let's move to 0, pi over 2, pi, 3 pi over 2, 2 pi, and what comes next is 5 pi over 2. I'm not sure about this value in degrees, but yeah. If you can see the pattern, this is pi over 2, 3 pi, 5 pi. The coefficient of pi, or the integer that multiplies to it, is an odd number. So 1, 3, 5, and possibly 7 pi over 2 is next, after writing 3 pi. Possibly, maybe it's correct, maybe not, but yeah. Right now, if you multiply the t-values, the respective t-values with cosine, you get 0, 1, 0, negative 1, 0, positive 1, and 0. And because the b is still 1, just copy paste from the t-values. They're the same. Alright, so let's start sketching the graph. Here is the point of origin. This is negative pi over 2, positive pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Now, negative pi over 2 and 0 is, it's over here. 0, positive 1 is over here. Amplitude, positive 1, negative 1. Pi over 2 is 0 over there. I won't dictate everything in each, but I hope you can see the pattern. There you go. Now that's the graph for number 14. Number 15. So it says here, use a reference angle and the rule of fourths to draw an accurate sketch of the following. So state the amplitude and period. This time we're not only required to look for the amplitude, as well as the optional b. You also have to look for the period. So here in number 15, y is equal to 3 sine t. The number that multiplies to sine is the amplitude. So a is 3. and sine t, there's no number in between sine and t, so b is still 1, and it said, based on what we know earlier, period is equal to 2 pi over b, and because b is equal to 1, let's say 2 pi over 1, it's still 2 pi. Now, based on what I know, the period will determine the t values that you will have to put to play. So this is going to be long, I'm afraid, but yeah, let's keep going. Negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. From negative 360 degrees to positive 360, these are all the values within that element. And right now, it says here 3 sine t. Multiply all the t values with 3 sine, not just sine, since this time our amplitude is not 1, so we include the amplitude when we multiply it with the t values to get the amplitude. So long story short, the values are as follows: 0, 3, 0, negative 3, 0, 3, 0, negative 3, 0. And for the t values, because b is still equal to 1, they're the same. So negative 2 t 0, negative 3 pi, negative 2 pi 0, negative 3 pi and 3, negative pi and 0, negative pi over 2, negative 3, 0, 0, pi over 2, 3, pi 0, 3 pi over 2, negative 3, 2 pi, this is pretty long, 2 pi and 0. Now let's graph. So the point of origin is expected to be in the middle. This is pi over 2, pi, 3 pi over 2, 2 pi. At the left side, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So from negative 2 pi, this is 0. By the way, let's install the amplitude. So over there, so here, just connect the dots. Plot the dots. There you go. And illustrate the curve. There you go. Now that's number 15. Let's move on to number 16. This time the amplitude is 4. The letter B is still 1. The period is 2 pi over 1, which is still 2 pi anyways. The numerator doesn't change if the denominator is just 1. For t, the values will be the same as expected. So we multiply the t values with 4 sine, and we get the following: 0, 4, 0, negative 4, 0, positive 4, 0, negative 4, and 0. And this time, because the b is still 1, we just copy paste from the letter t. Now let's tally. Let's finalize the coordinates. So negative pi 0, negative pi over 2, negative 4, 0, 0, pi over 2, 4, pi 0, 3 pi over 2, negative 4, 2 pi, and 0. Okay, let's graph. So here is the point of origin. Actually, I think I still have... Yeah, I still do have it. This is basically a template. I'm sorry. So it would save time because the t values are the same. From negative 2t to positive 2t, I'll just use that template. Negative 2t 0. Then here is our amplitude is positive 4 here, negative 4 at the bottom. So we write something like this. Okay, now let's connect the points using a curve. There you go. Now that's number 16. Let's move on to number 17. So y is equal to negative 2 cosine t. A is negative 2, but because there's absolute value in amplitude, so it's going to be positive 2. B is still 1. Therefore, our period is still 2 pi. Now, the t values will be the same, I suppose. As long as the b is 1, probably the period will still be 2 pi, and the t values will still be the same. Maybe, maybe not. But at least we have the grasp. So calculate negative 2 cosine whatever t value it is. The values are as follows. And for bt, because b is 1, copy paste. So let's make the coordinates now. Alright, now let's graph. The point of intersection is somewhere here. I mean, the point of origin. I'm sorry, I'll just use the sticker again. It's just the same anyways. Now, negative 2 pi, negative... Amplitude here is positive 2. Below is negative 2. So let's start putting the dots. There you go. Now let's make the curve. There you go. Let's move to number 18. So the amplitude is negative 3. Let's make it positive 3 because of the absolute value. B is 1. P is pi over 2 over 1, which is 2 pi. And so, yeah, the same values from negative 360 degrees to positive 360 degrees. Negative 3 cosine times whatever t value that is. we get the following: negative 3, 0, positive 3, 0, negative 3, 0, positive 3, 0, and negative 3. Because b is equal to 1, the t values are the same as the bt values. I know I'm being very repetitive right now, but later on there will be problems wherein b is not equal to 1. That's when we would do something else, but right now I won't discuss it. Alright, now let's graph. So negative 2 pi, negative 3 over here. Here is positive 3, here is negative 3. And now we graph. Oof. One mistake, all mistakes. At least you do get the point. Let's move to number 19. Number 19, given that a is 1/2 and b is still equal to 1, so period is still 2 pi, and the process is very similar to the prior ones that we answered. Alright, so sine t, it goes something like this: 0, 1/2, 0, negative 1/2, 0, 1/2, 0, negative 1/2, and another 0. bt, it's just the same as the values in t, because b is equal to 1 again. Maybe by now you can get used to what I'm saying. So let's jot the coordinates. Negative 2 pi 0, then 1/2 right here. Just tag along and we make the curve. Now I think that's it for this video. I'll be continuing. We'll be starting number 20 in part 2, but this is part 1. I hope you understand something at least. Thank you for watching.